Hello class. Today what we're going to do is look at permutations. So permutations is a special part of the fundamental counting principle that we talked about in the previous video. So for a permutation, it is just a set of distinct objects and order matters for these objects. So the one thing that you want to remember about permutation is permutations order matters. So if we have these letters A, B, C, X, Y, and Z, we want to figure out how many ways I can rearrange those and then count the number of ways that I can rearrange those. So X, Y, Z, C, B, A is one way I can rearrange those. C, Z, A, B, X, Y is another way, and so on and so forth. So we want to figure out how many total permutations there are. So the way that we do this is we take into account the product rule that we talked about in the fundamental counting principle. And so what happens in that first spot, so our first placeholder, we have 6 options. It could be an A, it could be a B, it could be a C, it could be an X, it could be a Y, or it could be a Z. So in that spot, we're going to put 6. So there's 6 options there. For the second one, whatever letter I chose for the first spot, I cannot use it again. So I cannot use A repeatedly. I have to use a different letter for the next one because I'm just worried about the order. So there's 5 options for the second one, 4 for the third, 3 for the second, for the fourth, 2, and then the last one we would know what it is. And so the way that we do this is we're going to multiply. So it'd be 6 times 5 times 4 times 3 times 2 times 1, because remember we have 6 options and we have 5 options for the second one. So it's still an and situation where we're multiplying. So 6 times 5 times 4 times 3 times 2 times 1 is, I believe, 120. Or 720. 5 factorial, so 720. So there are 720 different ways I can rearrange those 3 letters and do that. So the easier way to write this is called 6 factorial. So anytime you see this exclamation mark, it just means you're going to take whatever number it is, and then you're going to take that number times 1 less, times 1 less, times 1 less, times 1 less, all the way until you hit number 1. And this is called factorial, or at least in math it's called factorial. I'm sure in your English class it's called exclamation mark or exclamation point. Okay, so let's say we want, there are 8 yachts in America's Cup yacht race. I want to figure out how many ways they can finish that race. So there's 8 ways to finish first. So there's 8 boats that could finish in first place. Then there would be 7 that could finish in the next spot, and then 6, and then 5, and then 4, and then 3, and then 2, and then 1, and we multiply all those together. And so there are 8. So the way that we could also write this is 8 factorial. And you can use if you go to like Desmos or your graphing calculator, both of them have the factorial option. So 40,320 ways that those 8 boats can finish that race. And this is where we talk about up here. It says the order matters. So the order matters in the way that they finish the race. So these are always the questions you want to ask yourself on these questions is, does order matter? There will be eventually where it doesn't matter what order they're in. So let's say, and this is what's going to be more commonly going to happen, is you're going to be given a big set, and then you're going to take a subset of that and figure out how many ways we can rearrange that subset. So let's say we took the same 6 letters, so A, B, C, X, Y, Z, but I want to see how many ways I could rearrange 4 letters from those. So the way that we do this is there are 6 options for that first spot, so it could be A, B, C, X, Y, Z. But then once we choose that one, there's only 5 options for that second letter. There's only 4 for the third, and then 3 for the fourth. But after that, it doesn't matter because we're only picking 4 of them. So what we do is we multiply these because it's still and, so we're picking 1 letter, and then a second letter, and a third letter, and a fourth letter. So 6 times 5 times 4 times 3 times 2, or 6 times 5 times 4 times 3, that's going to give me 360. So the way that we write this is called a permutation. So a permutation has this, so it has this notation. So you're going to see this. So P and then parentheses N comma R. So N is the number of things that we have to choose from. So in that last question, that was 6. And then R is the number of things we're choosing. So that's 4. And then your calculator or Desmos can find, you can do this permutation. All you have to do is just Google it. You'll find some calculators for it. So permutation of 6, choose 4, and we get 360. So here is the permutation formula. This is what your calculator is actually doing. So this is the official permutation formula. And the way that we say this is it's a permutation of n things chosen r at a time. So it's read as a permutation of n objects taken r at a time. A lot of times you'll just hear it say n choose r, or a permutation of n choose r. Okay, and the way that we get this is you think of that 6. We did 6 times 5 times 4 times 3 times 2 times 1. So 6 times 5 times 4 times 3 times 2 times 1. And then we're dividing it by n minus r factorial. And so n is 6, r is 4. So that would leave us with 2 factorial. And 2 factorial is 2 times 1. And then if you think about if we divide, 2 divided by 2 is going to become 1. So that will become 1. And then 1 divided by 1 also becomes 1. And 1 times 1 is just going to be itself. And so what we're left with is 6 times 4 times 3 times, or 6 times 4 times 3, which is exactly what we did there. So that formula is just the formalization of doing what we did up here, the 6 times 5 times 4 times 3. All right. So let's look at this. We've got an example. We've got a 12-person community theater group. Club members select one person from each group to direct the play, a second to supervise the music, and a third to handle publicity and tickets and other details. So we want to figure out how many ways we can fill this position. So the one thing to keep in mind about this is we cannot use the same person. So if one person is selected to direct the play, they can't also supervise the music, and they can't also handle the publicity. That would just be too much for one person. So we're going to split it up and kind of divvy up everything. So there's going to be 12 people to choose from, and there are 3 positions. So we've got so if we want to do it the placeholder way, which we can, so we've got the person that's directing. There's 12 options for that. Once I choose the director, there's one person in charge of the music, so there'll be 11 people left to choose for the music. And then we've got the publicity person, and so there'll be 10. So that would be 12 times 10. Or we could do just a permutation of 12, choose 3. And if you do it either way, you're going to get the same answer. Your calculator is doing that same. So your calculator is going to do that 12 factorial divided by 9 factorial because it's 12 minus 3. But either way, you get 1,320. So that's how many ways we can fill those 3 positions from the 12-person community theater group. All right, there's one more specific permutation. It's called a distinguishable permutation. So in the first question, let's say we had like 6 different pieces of color, and we wanted to rearrange those. We could tell, so if we had like a yellow piece of paper and a green piece of paper and a blue piece of paper, and I shuffled them all together, like you could tell the difference between those 2. But sometimes you're not going to be able to tell the difference. So if you can't tell the difference, so let's say all those pieces of paper are called green, if I rearranged all those papers, then it would look exactly the same as the original, even though they're all rearranged. So what happens is this is called a distinguishable permutation whenever some of the items are not distinguishable and they looked identical. So we couldn't tell if we rearranged them in order, we wouldn't be able to tell. So if we did that, it would end up being 6 factorial, the ways that we could rearrange the paper. And then we divide out the number of that specific one that can not be told the difference between. So those 6 pieces of green paper, we would divide that by 6 factorial because there's 6 factorial ways to rearrange that. So there's 720 ways that we could rearrange them if they were different colors. And then we want to divide out all the ones that are the same. So then that would also be 720. And so there's actually only one way that we could rearrange those 6 pieces of green paper and tell the difference if there was. So the way that we do this for the distinguishable permutation is you take the total number and then we do factorial. So however many things we have, factorial divided by all of the individual things where if we rearrange them, we can't tell the difference. And so it'd be like n sub 1. So if I have like 4 things or 3 things that were the same and then multiply those, and those are all going to be multiplied and then divided into the big number. So the way that we do this for this example is we have 6 pieces of paper, 4 of them are blue, 2 of them are yellow. We want to figure out the number of ways I can rearrange those. So I could go blue, 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 yellow, yellow, or I could go blue, yellow, blue, yellow, blue, blue, and we want to count up all those ways. So the way that we do that is we just take the total number of ways I can rearrange the paper, so that would be 6 factorial. Then I'm going to divide them by all the ways I can rearrange the blue ones, so that would be 4 factorial. And then I'm going to divide them by all the ways I can rearrange the yellow ones, which would be 2 factorial. Now I'm going to put parentheses around here because I know I want to do that operation first. And I already know what 6 factorial is because we did it up above. So that would be 720. 4 factorial, it's 4 times 3 times 2 times 1. So that would be 24. And 2 factorial is just 2 times 1, so it would be 24 times 2. So what happens is we get 720 divided by 48, and you get 15. So there would be 15 ways to rearrange 4 blue pieces of paper and 2 yellow pieces of paper in order. So you still have to ask yourself, does order matter for a distinguishable permutation? But some of those things you wouldn't be able to distinguish if we rearrange them. So that is a distinguishable permutation.